Crastinum hydrogen ink. So you may be wondering, what are PMS? Well, my loving hydrogen friend, let me tell you. To begin with, PEMs means proton exchange membrane fuel cell, PM. And they are well suited to power applications where quick startup is required, such as automobiles or forklifts. Single PM units range from several watts to several kilowatts and can be scaled into larger systems. The largest to date is a 1 megawatt PM stationary power plant. PM fuel cells operate at relatively low temperatures, have high power densities, and can be very output quickly to meet shifts in power demands. PM systems are available today for a variety of applications where sales focus in the telecommunications, data center, and residential market, primary or backup power. And to power forklifts and other material handling vehicles, PM fuel cells are also used in buses and demonstration powers passenger vehicles. Major auto manufacturers anticipate the start of commercial fuel cell vehicle sales around 2014-2016. PMs are fueled with hydrogen gas, methanol, or reformed fuels.
To high-temperature PEMs, or HTPEM fuel cells, they're similar to PEM fuel cells, but operate at higher temperatures between 250 degrees Fahrenheit and 390 degrees Fahrenheit. HTPEMs are often integrated with fuel reformers, permitting operation using a wider variety of input fuels. HTPEMs can be used to power vehicles as range extenders for batteries and small-scale commercial buildings and homes. Now, what does this have to do with real vehicles? Well, most fuel cells designed for use in vehicles produce less than 1.16 volts of electricity, far from enough to power a vehicle. Therefore, multiple cells must be assembled into a fuel cell stack. The potential power generated by a fuel cell stack depends on the number and size of the individual fuel cells that comprise the stack and the surface area of the PEMs.
Here is the Toyota Mirai, the first hydrogen fuel cell car to be commercially sold by Toyota. Toyota has done a very nice job in keeping all the information about the Mirai on one page, and the diagrams they provide are very helpful. So I'm going to be explaining on how it works. Here, there's a section all about how the car works. And as the title suggests, it all starts with hydrogen. The hydrogen is stored in these canisters, which then pump the hydrogen into the fuel cell stack, while the air from the outside is taken in through these vents, and the oxygen is used from the outside air. These two are mixed in the fuel cell stack where a reaction takes place, and the reaction is then converted into electricity by the fuel cell. This electricity is then usable by the battery that powers the car like a normal electric car, which moves the car forward, obviously. And finally, nothing but water vapor comes out of the car, which is healthy for the environment. Toyota has also done a very good job emphasizing the fact that their hydrogen canisters are specifically designed to prevent any hydrogen from leaking, as hydrogen is very flammable and can explode very easily. They have sensors that stop the flow of hydrogen in the case of a high-speed collision to minimize any damage that could be caused by hydrogen leaking. Finally, Toyota provides a diagram and the layout of all the parts of the Toyota Mirai. So first, here is the power control unit, which decides where the energy is going to be used, either the boost converter here or the battery in the back. The motor is what makes the wheels spin, and the boost converter is what powers the motor. The fuel cell stack is where the energy is converted. The hydrogen tanks are obviously where the hydrogen is stored. And the battery is where the electricity goes from the fuel cell and is used throughout the car. And now I'm going to pass it off to Jack to explain more in depth of what the fuel cell does.
PEM fuel cell. Hydrogen gas first enters the cell and moves to the anode. In the anode, electrons are released to form 4 H+ ions. These electrons then move into a circuit. In the circuit, what it needs to be powered is powered, and the electrons continue on back into the fuel cell through the cathode. In the cathode, the H+ ions, as well as the electrons and an O2 molecule from an oxidant that had entered the cell, bond to form an H2O molecule. Then, this newly formed water exits the cell, along with heat and excess fuel.
it going?